Now, today's session, I would talk about how this big data world started. I mean, how these tools and technologies started coming, how it evolved over time, and what is the current trend looks like, right? What mostly new startups around product development they are doing to get a new product onboarded and all. So I would talk about these lines, and this should give you a good idea about the landscape that, okay, this is how things evolved, and this is where future advancements looks like. Okay, so let's get started. Why this big data tools and technologies came into picture at the first go? I mean, I would see the chat, what you guys say. I mean, what do you think? What's the need to have something like Hadoop and things like that? When your traditional systems cannot handle some kind of data or the volume of data, then there was a need that, okay, we need newer tools and technologies in order to handle that, right? And that's where we say that big data has three characteristics or five characteristics: volume, variety, velocity, right? Many things, right? There are a lot of definitions of these, but again, that's more theoretical. But I would say the volume of data, the variety of data, the velocity of data, all of these contribute to the fact that it's a different kind of data that we cannot handle through our traditional system. And Hadoop was the first thing that came into play in order to help with this, right? So that's where you will hear Hadoop a lot, even though today it is not that relevant the way it used to be earlier. Now, if I am someone who has to process some huge amount of data, which I cannot process using a traditional system, then I would first think about how can I store such huge data, because the data is so huge that I cannot store it on my laptop or I cannot store it on a big computer also, let's say. Then how I am going to store that? That is where the notion of distributed storage came into play. That means, okay, is there a way that if I cannot store my data on one machine, then probably I can divide this data and store it on 100 machines, right? Or if not 100, then 500 machines, whatever it is. That's where we talk about distributed storage. Distributed storage, right? So we are deviating away from one monolithic system towards a cluster, right? So we say that, okay, I know that one machine is not capable enough, so I need a cluster of machines or cluster of nodes which can handle the problem. Now that's about storage. That's fine. For storage, Hadoop gave you HDFS, right? And a lot of things came into HDFS that, okay, how do I access this files? How do I put the file to HDFS? So you have put command, right? How do you access? The same way, using Linux kind of commands, you can access. Apart from that, now, if data is sitting on many machines, then what if one machine fails? Then the factor of this replication factor was coming handy. That, okay, the replication factor is 3. So the block which is stored on one machine will be stored on some other machine also. If one machine fails, we can recover from there, right? Now, let's say you have a 40 node cluster, 40 node Hadoop cluster, and you have, let's say, for example, 1 TB data, 1 TB data. Now, is it fair enough that I say, okay, this 1 TB data I store on one machine and that's it? Is it a fair way? Then why do we have a cluster, right? The cluster is just to make sure the load is evenly balanced. We divide this 1 TB and put it across the machines. See, that's an internal thing, but I'm telling you that what happens. So how exactly this 1 TB would be divided if we have a 1 TB file? That's where the factor which is called as a block size came handy. And this block size is 128 MB, right? So that means if you divide 1 TB by 128 MB, you will get 8,000 blocks of data, right? Now this 8,000 blocks would be divided across 40 machines. right? So roughly, there is no guarantee, again, system will see as per the load and all. So roughly each machine here will get around 200 blocks, right? 200 blocks. And if you see, considering the replication factor and all, totally 1 TB file will have 8,000 blocks, but there would be a replica. That means each block will have 3 copies totally. So totally, you would have 20,000, 24,000 blocks, and 3 TB would be stored across the cluster. 3 TB would be stored, right? So that's what we see in this distributed storage, which is HDFS. I hope this is clear, right? Okay. Now, storage part is taken care. What we have to think about now, it's your processing part, right? It's your processing part. So once your data is stored, how do you process it? Can your normal C, C++, Python, Java program, can you run directly on this? Can you run directly on this? You cannot. You cannot run those directly because your traditional programs can work when your data is sitting on one machine, right? But now data is no longer sitting on one machine. Data is spread across the cluster. That's where you have a thing like MapReduce, which says, okay, I know how to handle it. And in terms of map and reduce, we can handle. And MapReduce, there were two things, map and reduce, right? And always, if when someone was directly writing MapReduce, the thought process was, let me bring more computation towards the map phase because it gives us parallelism. Reduce is just to aggregate, right? And in between map and reduce, there are two more things, which is sort and shuffle. And then it goes to the reduce. That's how it used to be. And shuffle is always a very, very costly operation, right? So I won't go too much into MapReduce because you won't directly work on MapReduce these days, right? Even I have given some understanding in the course that should be good enough. Why have we deviated away from MapReduce? Why have we deviated away from MapReduce? That's a very important question, right? Because MapReduce was the first thing that came into play. Then why we just deviated away? The reason was simple. MapReduce uses there was a lot of IOs actually, input, writing to the disk, reading from the disk, right? Lot of IO involved, and that was very time consuming. If you see a small MapReduce job, that also takes a lot of time. So it's time consuming because it uses the disk heavily, and anything which is too much dependent on the disk IOs, that becomes a bottleneck. And that's what happened, right? So if we have a series of 5 MapReduce jobs, then you have 10 disk IOs, which is huge, right? Which is huge. Moreover, even for some simple computation, a complex Java code is required, which we have to write a map class, a reduce class, a main method. What we can do in other technologies with 2 lines, here we can do in 200 lines. Then I don't think there is a point to do that. So MapReduce has certain limitations that way. And that's where you see that everything is defined in the form of MapReduce. Even if you have to do a filter, then you are bound to this MapReduce framework. You will say map is working, reduce is not. I mean, ideally, we should have said, okay, dot filter, and it should be done ideally, right? So that's where MapReduce has a lot of problems and newer technologies have emerged on these lines, right? And then again, we have Yarn, which is another component of Hadoop, which is like like a operating system for data, right? Which manages the resources, resource manager, right? So these are the 3 things. Okay. Now that's fine. Now there are a bunch of ecosystem technologies. That means MapReduce was hard and it was difficult. That's where they have something called as Hive. Hive is still quite relevant these days also, right? So Hive says that, okay, no need to write complex MapReduce. It's okay. You write it using some simple SQL kind of style. And I will internally convert it to a MapReduce, right? So it's like an abstraction on top of MapReduce, that it's a SQL way of doing things, but internally it will happen in MapReduce type, right? So Hive became quite trending, right? People deviated from MapReduce to Hive, right? Now, in today's world, if you see, Spark has came in and very, very prominent. Spark has multiple flavors, like your PySpark thing, and apart from your Spark with Scala. Even though Spark code can be written in Java, but PySpark and Spark with Scala are two most trending things, right? So Hive and Spark, people think that, okay, what is the need of Spark? See, Hive still works underneath the MapReduce way. That means it's making easy to write the code, but internally the job will take time because internally it's a MapReduce job, right? So that's where we needed something which do not depend too much on the disk. Like the limitations of MapReduce, we have to eliminate as a compute engine. So Spark evolved, which says I am much more generic. Generic in the sense it's not limited to just MapReduce. It is in memory, right? In memory. So this kind of solves the limitations of MapReduce and says that, okay, I'm not too much dependent on disk. I will keep the data in memory until we get the final answer in most of the cases, until a shuffle is involved, right? So it keeps holding the data in memory for much longer than what MapReduce could. MapReduce also works in memory, but it keeps writing to the disk and takes it back, right? So that's where Spark says, I'm not limited to MapReduce. If you do a filter, you can just say dot filter. You do not say that map is working, reduce is not, right? And I will keep holding the thing in memory for a much longer time so that your disk IO is reduced. And Spark also has evolved a lot. It all started with RDDs, resilient distributed data sets, right? It all started with RDDs, resilient distributed data set, where it's more like an unstructured thing, right? There is no structure involved. And it certainly was better than MapReduce, but still it was a, still a good amount of effort was required. It's more like a programmatic way of doing, right? So see, I will tell you the data engineering world is moving in one simple direction. Can we give a SQL interface to do things? Can we give a SQL interface to do things? Because most of the people knows SQL. SQL is super easy. And if they give a SQL interface to get things done, then a bigger crowd can use that tool and technology, right? So you see, Spark started with RDDs, which is a way of writing code, right? And the code will be much more concise, but still it's hard, right? Then data frames came into play. Data frames came into play, and this was a abstraction on top of RDDs. So this is RDDs with some structure, and you can treat it like a table, right? So this is again simpler than RDDs, but not again like SQL that you are writing. And then came Spark SQL. This is again that if you are a SQL person, you write your SQL query, and internally, whatever job is there will be executed. So underlying, it's not normal SQL, but kind of under the hood, it's still distributed computing that will take place, right? So you see how it slightly or slowly evolved and started from programmatic style only to Spark SQL it evolved. So I would say if you have to write the code in Spark SQL, that's a SQL very easy. Data frames is again medium, RDDs is hard. And MapReduce is super hard, if I have to say that, right? But then you would say, is there any time then we will write the code in RDDs? Right? When Spark SQL is there any time then we will write the code in RDDs? Can be a possibility when you have unstructured data that then you will read it as RDD, give it some structure, as soon as possible, and then change it to a data frame and then work with Spark SQL, right? So there can be chances that when the data is very unorganized, structured, logs, data and all, you might read it as a RDD, quickly give it some structure, and then work using Spark SQL or data frames. Now you might ask, data frames or Spark SQL? When we have Spark SQL, then will we ever work on data frames? See, as and when you go downside, that means Spark SQL. Spark SQL is easy, but the flexibility is very low. That means anything that can be done in SQL kind of style, that only you can do here, right? But as you go up, that means data frames give more flexibility in terms of what you can code better than Spark SQL. RDD is very, very flexible. Anything you can do, right? So you have to see your use case. If your use case cannot be met through a SQL way of doing things, then you would choose data frames. If not data frame, then RDD. That's how you have to think. In interviews, I will say data frame and Spark SQL gives almost the same performance. But in interviews, they might be more interested to see whether you know data frames or not. Because in Spark SQL, they won't be able to judge your Spark knowledge, right? So mostly in interviews, they might be checking on data frames more than Spark SQL. They might not ask much of RDDs, by the way. So that's how the landscape evolved in terms of your compute, right? So I talked about HDFS, I talked about Yarn, MapReduce, Apache Spark. Now, when you go for interviews, right, mostly they will deep down on the performance tuning aspects. And always remember that in big data world, when you are talking about performance tuning, it mostly revolves around, is there a way I can avoid shuffling or I can at least reduce shuffling? Is there a way? Is there a way you can reduce shuffling or avoid it altogether? Very, very important. Everything mostly revolves around these lines, right? So let's say you are doing some joints, right? Then I would say whenever you are doing some joints, try to eliminate unnecessary data as early as possible. If a filter is there, then you filter it, because filter is does not require a shuffle. You eliminate the data, and when you do a join or a group by, then data movement or shuffling is involved. So why you want to shuffle a lot more data, right? You want to avoid unnecessary data at early stages. So avoid or filter data as early as possible. Then there are a lot of join techniques which help you to make sure we shuffle less data or we do not shuffle any data. For example, we have like a broadcast join, right? What is a broadcast join, by the way? A broadcast join is where when you have one small table and one big table and you want to join this. If you do a normal join, then ideally both the tables will be sent on some other machines. Shuffling of those two tables will happen and then join will take place. But when you say you want to do a broadcast join as one of your table is small, then what will happen? The bigger table will be kept intact on the machines. Let's say bigger table is stored on node 1, node 2, node 3, and node 4, right? And block 1 of bigger table is here, block 2 is here, block 3 is here, and block 4 is here. What will happen then? This bigger table will be untouched, and the smaller table, the complete copy of that will be sent. So I will write SM, small table. Small table, complete copy will be sent to all of these places, right? Now, this block 1 can be easily merged with the small table, which is sitting on node 1. So ideally, this block 1 do not have to be moved anywhere. It can happen on the same machine where it is sitting, right? Same way, all machines are now capable to work locally without movement of bigger data. Which one was bigger data? B1, B2, B3, which are blocks of a bigger table, right? So you might see a trade-off that, okay, small table, we should have multiple copies then, right? It will consume more space. See, ideally, when I'm saying small table, it's very small, might be 10 MB. You can make it, change it to 25 MB, 50 MB, 100 MB, right? Whatever. But this is very small. It's not big. Even if you have 20 copies of such thing, which is 50 MB, then how much it is? Hardly 2 GB, which is very small as such, right? So I'm just giving you an idea that in terms of your optimization, always try to reduce the shuffle. Not every time you can avoid it, but you can always think of minimizing it. In this case, it's totally removed, right? Okay. So when going for Spark interviews, mostly they will drill down on the optimizations, which will revolve around these lines. I have covered in my program very, very well. So you do not have to worry so much. Okay. Now, again, if there are 4 white transformations is the one which includes shuffling, right? If there are 4 white transformations, then you will mostly have 5 stages in Spark, right? That means every time you have a white transformation or a shuffle is involved, just to showcase you that it will create a new stage, right? So when there are a lot of stages, your thought process should be that can I reduce the number of stages? Because if there is just one single stage, that means there is no shuffling involved. And that's not possible always, by the way. Right? Okay. Now, this is about MapReduce, Spark, right? Spark is the most important thing in this course, whatever I teach. And it's even more important than cloud. Cloud knowledge cannot judge anyone. Cloud knowledge is more like that, okay, how to use cloud. You are end users of it, right? You will not even get to know too much internals because it becomes a black box. Black box in the sense, let's say it's a proprietary technology, let's say, right? They won't tell you what they do internally. For example, any technology, let it be, right? If it's a technology by some company, they won't tell what happens underneath. And you use it like an end user and you just get the results. So the learning curve is low and that cannot judge anyone. Even a fresher will be at almost same level there, and a 10 years experience also will be mostly at the same level. More 10 years experience person will be having more knowledge around the wider ecosystem, right? But if they say that I know Athena, and Athena, if someone a fresher know or a 10-year experience, I don't think you can do it differently. It would be on almost on the same line. But the differentiating factor will be in open source technologies like PySpark. That how much internals you know. And that's where a fresher certainly might not be able to answer this much what a 5, 6, 7 years experience person or 10 years experience person can do. Right? Because there are a lot of internals to it. Whoever knows well is ahead in the game. And that's why even in interviews, even though we say it's a cloud focused world, but in interviews, they will not have too many questions for cloud to ask. They will have more questions regarding internals of Spark and all to ask, because more questions can be framed from here. There, it's almost the same thing for everyone. I hope that makes sense to you, right? Now talking about cloud. Why we moved to cloud? Like Spark and all was going very good. Still, it's going very good. Why cloud then? Let's say in cloud, the equivalent thing, let's say Azure Databricks. Azure Databricks, right? Why cloud Azure Databricks when we have Spark and things like that? One thing is they are trying to give a bigger ecosystem. It's not just Spark. It's a Spark-based thing, but it provides a lot of other features like you can do collaboration with notebooks, a lot of other things, good security. So Databricks was created by the creators of Spark, and they say that, okay, if you use Databricks, the performance will be better than if you use the plain vanilla Spark, right? That means whatever knowledge you have of Spark is still super valid when you work with Databricks, because in Databricks you write Spark code. The only benefits that you get is your code will run faster. You can easily create a cluster. That means it's making your life easy. Because earlier you would have procured some 20 machines somewhere, or your admin, not you. Your admin would have procured 20 machines somewhere. They would have installed Spark manually. If Spark issues come, setup issues, they would debug. It takes time. it's hard to do, right? Because installing such frameworks is difficult. That's where people want easy way of installations, and people want that, okay, if I do not want to use, I get rid of it, right? And I want a optimized cluster where the settings are optimized. So that's what Databricks say, that same code, whatever you run there on plain vanilla Spark versus whatever you run on Databricks, in Databricks, it will run much, much faster, right? So created by developers of Spark, right? Created by developers of Spark. You can easily create a cluster and it's optimized. Easily create a cluster on click of a button, on click of a button, and it's very optimized cluster. I hope this is clear, right? And we have notebooks there. We work on notebooks. We can share those notebooks with others. A lot of other features. So they're building a big ecosystem. That means if anything related to data science, anything related to AI, anything related to data engineering, all can be done at one place. So it's like they are making a big ecosystem, right? There are many startup, I should not say startups, now are very, very reputed companies like even Snowflake on those lines, who are doing the same way, right? But Databricks is one of the well ahead companies, because if anyone was running Spark locally, right? If anyone was running Spark on premise, where they will move? Will they move on Snowflake or will they move on Databricks? They will move on Databricks because Databricks internally is working on that foundation, right? So Databricks has a lot of adoption that way. And if you know Spark, then it becomes super easy, because on top of that, there are not many things there. I'll talk more about it, but that's how this is, right? Now, how do Databricks start? See, of course, when you say Databricks, it's two things. If you say 20 node cluster, then a 20 node cluster. Okay. That means the hardware. So anyways, you have to give this cost. Earlier also, if you would have set your Spark on a 20 node cluster without Databricks, you would have paid that cost anyways, right? So that's a hardware cost. Earlier, when you were using an open source Spark, you were not giving any software cost, but you want to optimize Spark, you want without any headache on a click of a button. So you pay a software cost also, right, for installation, right? So that's where uh, they charge you a cost for that. And that also depends on how many nodes you have and all of it. So this is also there, software cost. So total cost is hardware cost, that is of the underlying nodes which are there, plus the cost of maintaining the software and all of that, which is like installation of Spark. So these two costs are there. This additional cost is there. This is additional. Earlier, when you would have done open source Spark, this was not there. Now you might think then it's costly. But what Databricks say that you pay this additional cost, do not worry, because the savings that you will get will be much more than what additional cost you are paying for software, right? I hope this makes sense. Now, generally, I mean, I'm not talking about Databricks now, but generally when you go to cloud, there are two types of services. Two types of services in cloud, right? Two types of services. What are these two types? One is serverless and another one is serverful. Now I will tell what these two are and when to use what. For example, if you have to ask what is a serverless, can you tell me, is Databricks serverless or serverful? So Databricks is when we create a upfront cluster that I need a 4-node cluster, and whether I use it or not, I'm built for it. That's a server full. That means you upfront take some dedicated resources and say, I want this. Sorry, server full, this one. Yeah, right? You say, I need a 8-node cluster. Whether I use or not, I pay for it. Dedicated resources you have at your end. That's server full. Example, Databricks. Serverless means, okay, you say that I have a query to run. I do not want any dedicated resources. I will pay based on amount of data I scan or amount of whatever based on my usage. That is serverless. For example, Azure Data Factory. In case of your AWS, it is Athena, right? You are most, in case of your Athena, you are built for amount of data you scan, right? So, I mean, when you use serverful, you pay even if you do not use the services, if you have taken it upfront. In serverless, you only pay when you use it or based on amount of data you scan, right? So when to use what? It depends totally. If you have a lot of things happening throughout the day and a lot of ad hoc querying throughout the day, then you would want dedicated resources. If you have, if you need dedicated performance, that okay, my performance, it's a time critical job, right? I want the result as soon as possible without any delay. You should go with serverful, right? Because then only you can get that kind of performance. But if you have a daily job which runs at 10 o'clock, and it's okay that whether it takes 1 hour or 1.5 hours, it's not a time critical job. You want results in the morning. Then why would you turn on so many resources and views, right? You will go with serverless thing. Okay, it's okay. Even if it takes 1 hour, 1.5 hours, anyways, I will get results in the morning because I have to check the report in the morning, right? And I do not want any dedicated resources. Use the shared pool of resources that you have and give me the results, right? I hope this is clear, right? So these two are the kind of services. Most of the services can be divided in these two ways. Can you talk about Azure Synapse for who have learned? Is it serverful or serverless or both options? Both, right? So you have both the options. Either you can create a dedicated cluster, right, where you pay heavily for that. Otherwise, you can use serverless, where you kind of pay based on amount of data scanned. Can you tell me what are the charges based on amount of data scanned? What are the charges? $5 per TB. $5 per TB of data scanned, right? And you pay minimum for 10 MB. You pay minimum for 10 MB. That means mint 10 MB. Even if you are running a query which scans 1 MB of data, you are built for 10 MB. 10 MB would be how much? Very, very less. 10 MB divided by 1 TB. That's a very small number, right? And if you multiply with $5, you get that, okay, hardly you pay 25 paisa or something like that, right? I hope this is clear. Now, whenever you are seeing going with serverless, how would you optimize? Optimization is you reduce cost, right? Reducing cost can happen only when you scan less data because you pay based on amount of data scanned for most of these services, right? How do you scan less data? Let's say if you are using Synapse serverless or Athena, right? How you make sure to scan less data? Always use column-based file formats. Column-based file formats, for example, Parquet, ORC, these kind of things. Let's say Parquet, right? So if there are, let's say, 20 columns and you have to deal with 5 columns, you ignore the remaining 15 and you just concentrate on 5. So considering all columns are of same width and all, you are eliminating 75% of the data which you are not even touching from the disk. From the disk itself, you're not touching that data. You're not scanning that data altogether. That's what the advantage of column-based file format is. So use right column format, right columnar file format, right compression techniques, right? All of those things would be there. I hope this is clear. Okay. Predicate push down, that means from disk itself, you retrieve less data, all of them. So that's how we move to cloud so that things become easy. We do not have to maintain our own setups, right? On a click of a button, we can create our cluster, all of that. Because handling on-premise is tricky. That means you have to procure machines, install ourselves, things like that. So cloud is becoming famous just because of these things that we can be much more agile. If tomorrow you want to work on Databricks, you can create a cluster today or tomorrow itself and start working. But if you have to do it on premise, it would require weeks. right? That's how it is. Now, I talked about this Databricks. There is one very, very important thing which Databricks do, or which many companies are doing these days. So two trends, two things which are happening these days, I would say. Number one, giving a SQL interface to do things. That means implementation wise, things will get easier over time. That's what the trend I see. That means if something is hard to work with today, they might give an easy way for you to work with that because they want more people to work. But knowing the internals is the key, because anyone can write this SQL. Because if I am someone as a developer with 10 years experience, someone is with 2 years, and we both are writing SQL, that means we cannot be differentiated there. It's almost same. But how much internals related to a system that will become a differentiating factor among people, which will tell who is a good developer versus who is a medium developer. The second trend is around Lakehouse. Lakehouse, right? Implementations. Lakehouse implementation. Now, if you see Lakehouse, this is a trend right now, build of two things: a data lake, a data lake, a data lake, and a data warehouse. Okay. Yeah. So I guess you get that data lake has certain capabilities, data warehouse has certain capabilities. See, data lake was all good. Data lake was all good. You were able to store any kind of data, process it, and all fine. But the challenge was quick retrieval or getting that asset properties. That was not happening. That's where we require things like a data warehouse, which is meant for quick reporting and all of those stuff. But that requires us to transfer this data, whatever we process here, to a data warehouse. So this is like maintaining two systems, getting into the integrity of two different systems, and even moving of this data from data lake to data warehouse takes time, right? So is there a way that we can have one single system which can give the best of both, so that there is no data movement involved, right? That's where the concept of Lakehouse is there, and it's still under refinement. I won't say someone has a very uh, perfect Lakehouse, because many new startups, if you are someone who is a lot of technology enthusiast, then if you have to open your own startup, it can be on that line that, okay, can I design or can I implement my own Lakehouse and customers use that? A lot of good startups are around this lines, because still it's under refinement. It's not a perfect solution by anyone till now, right? Because when you say that I have processed my data in data lake using compute engines like Spark, and after that you move this data to a data warehouse, there is a latency involved, right? It takes time. Moreover, in data warehouse, it will be stale data. Might be you are doing this transfer activity every 4 hours. So this data would be 4 hours late, and it takes time also to do that. All of those things are there, right? Even many startups and all have implemented their lakehouse, but still they do not get the same kind of quick performance. See, if data is there in data lake, you can process it very, very well. But can you fire database kind of queries to say that I want this particular row, get me instantly? Can you get that performance from data lake? No, right? So even this lake house is built for that you get a millisecond latency query running also. That means you have high throughput queries which are taking time, processing a lot of data, lot of joins, group bys, all of that. Also, you have query where you say, okay, get me this record very, very quickly. Also, not just that, asset properties, right? How to implement asset? That means uh, some record we have to change, or some record we have to delete, some record we have to insert. Is that possible just like a database or not? That means getting database kind of features is something which we are looking along with our data lake, right? And again, I'm saying many implementation, even in my course, I have talked about Databricks, but it's not as performant as a database would have been, right? It's not that quick in terms of data lake side is taken care neatly. But about this side, for reporting, for getting instant querying, all of that, there are a lot of optimizations are going on right now, right? So this is what the current trend is, and you will see many things coming on these directions. And this is an important concept to why maintain two systems when one system can do it, right? Because you are paying for two systems, then you are taking the security measures and whatever compliance issues for two systems you are dealing with, right? You are dealing with stale data. You are paying extra to move this data, a lot of them. I hope this makes sense, right? So, I have given you some broader idea today in this session, right? I tried to put it like a story all together. I hope you would have enjoyed it, right? This is what I wanted to communicate today.